Hello and welcome to another Math and Physics with Meghan video. Today we're going to be going over a different type of factoring called complex trinomial factoring. So in a previous video I talked about simple trinomial factoring, which was a slightly different process for a slightly less complex or more simple type of trinomial. Today we're going to be going over factoring for the complex trinomial, which has the form something like this. So in particular, you'll notice that the major difference is that we have a number in front of the x squared, or a coefficient in front of the x squared. With the simple trinomial factoring, the number in front of the x squared was a 1, or we didn't see the number, it was just the x squared out in front. So the fact that there is a number in front of the x squared term here is what makes this complex trinomial. Okay, and a complex trinomial has a slightly different set of steps and a little bit more complex set of steps than the simple trinomial. So kind of prepare yourself mentally for that. So to get us started here, I'm going to label the numbers in the equation, this example equation that we're going to use. So the number in front of the x squared is referred to the a value. The number in front of the x is the b, and then the number by itself, the constant, is referred to as c. So the first step, we're still going to be looking for two numbers that add to the b value. In this case, that's 11. But now, instead of looking for two numbers that just multiply to c, we need to look for two numbers that multiply to a times c. Okay, so in this case, our a value is 2, our c value is 12. 2 times 12 is 24. So we're looking for two numbers that multiply to 24. Okay, so you're going to take a moment to kind of try to figure out what those two numbers might be. As I've mentioned before, kind of a good starting point is to start with the second equation here and think, okay, how can I get 24, right? There's a few different options. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and vice versa. We can flip all of those multiplications as well to get 24. So then we're just going to go along this list and see which of these two numbers add to 11. Well, that's going to be 3 and 8, right? So our two numbers are 3 and 8. So 3 plus 8 is 11. 3 times 8 is 24. So a lot of times this type of factoring will be referred to as decomposition. And that's because of this next step that we're going to be doing. So we're actually going to be decomposing the middle term, the 11x, according to the two numbers that we just found. So you actually want to keep your first term, your 2x squared, and your last term the same, plus 12. And we're going to be decomposing. So instead of 11x, we're going to write 3x, because we had a 3 over here, and an 8x. Okay, so 11x becomes 3x plus 8x, according to the two numbers that we found on the right-hand side here. Okay, so that is what we're looking for. So now we've got four terms. One of them is an x squared, one of them is the regular constant term, and then two terms with x. What you're going to do is you're then going to place brackets around the first two terms and the second two terms. And we're going to common factor each of the brackets. So we're going to look at the first bracket, 2x squared plus 3x, and think, what can we take out of that? What's common between those two terms? We can't really take out a number. There's no number that divides 2 and 3 evenly, besides 1. But we can take out an x. So I'm going to take out an x, because that's common between the two terms. And what's going to be left inside the bracket? Well, you can, in order to common factor, you can think, okay, what's going to happen to these two terms if I divide by x? That's what we mean by taking out an x. We're dividing by x. So that's going to leave us with a 2x plus 3. So one of the x's cancels out from the 2x squared, and then the 1x cancels out from the 3x. Okay, then we're going to do the same thing with the second bracket. So we've got ax plus 12. We have to think, okay, what number can come out of both 8 and 12? Well, a 4 would divide both 8 and 12 evenly. So let's take out a 4. We can't take out an x this time because only the first term, the ax, has an x. 12 doesn't have an x, so we can't take an x out there. Okay, so what's going to happen to these two terms when we divide out a 4? And you don't always have to write this in. If you can do this in your head, that's completely fine as well. But I'm just writing it in for clarity now. So ax divided by 4, 8 divided by 4 is 2. So that's 2x. The x stays. Nothing happens to it. And then the 12 divided by 4, that's 3. Now, at this stage here, this is kind of a critical stage in terms of making sure that you're on the right track. Because what you want to look for at this stage is that the two brackets that you got when you factored are the same. Okay, those must be the same. If they're not the same, then we've made a mistake somewhere. We should go back and check our steps and see if we can find the mistake. Okay. The reason that has to be the same is that becomes one of your factors. Okay. So that 2x plus 3 becomes one of your factors. The second factor comes from the numbers that are in front of the two brackets. So we've got an x and a plus 4. So that becomes our second bracket, or our second factor. So x plus 4. Okay, so our final answer here is 2x plus 3 times x plus 4. So that's it for complex trinomial factoring. As I said, if you want to also review simple trinomial factoring, I have a video for that. Otherwise, if you found this video helpful, feel free to leave a like. If you have a question, feel free to comment and share with your friends if that is something that they need help with as well. So thanks again for watching this Math and Physics with Meghan video. Have a great day, and I'll talk to you soon. Bye-bye.